Welcome to today's Explainer. We're about to completely reframe something that pretty much all of us interact with every single day, often without even realizing its true power. Yep, we're talking about applied mathematics. Now, go ahead and forget all those old school day anxieties. Today, we're diving straight into the research to reveal how math is actually a highly practical, everyday toolkit. We're going to blend financial wisdom with spatial sense to literally make your life easier, your finances stronger, and the physical world just a whole lot easier to navigate.
Look, let's be real for a second. Almost all of us have stared down a complex string of equations, rubbed our temples, and asked ourselves that age-old question, when am I ever actually going to use this? We spent years learning all these rules, but the connection to our actual living, breathing reality, well, it sometimes feels completely severed. But the source material we are unpacking today answers that question directly and emphatically. You use it all the time. By making these seemingly abstract mathematical ideas totally tangible, we build real confidence, turning what used to be a dreaded subject into a totally vital adult life skill.
To get us to that point of total confidence, here's our quick roadmap. First up, balancing equations and finances. Second, conquering 2D space with perimeter and area. And finally, step 3, going 3D by exploring volume and capacity.
Okay, let's dive right into this. Our first conceptual foundation is balancing equations and finances, making invisible numbers tangible.
You know, when we talk about algebraic principles, it's so incredibly easy to get lost in the X's and Y's. But what the research really emphasizes is that algebra at its absolute core is simply about balance. I want you to think of abstract algebra like a physical balance scale, which is the exact model our sources recommend using. Your personal budget, it works the exact same way. You've got income on one side, expenses on the other. Solving an equation is essentially the precise act of balancing your monthly budget. Mastering percentages and ratios through these physical models is absolutely crucial for personal finance. When it clicks that a ratio is just the relationship between the weight on the left side of the scale and the weight on the right, suddenly concepts like interest rates, your savings percentages, and your debt-to-income ratio just make perfect sense. It's not just math anymore, it's financial survival.
Now that we've got our budget balanced out, let's zoom out from the equations and step onto flat surfaces. Section 2, conquering 2D space, specifically perimeter and area. Before we add any real complexity here, let's clearly separate two core geometry concepts, just as the source texts do. Perimeter is simply your outer boundary length. Think of it as how far you'd walk if you trace the exact edge of a shape. Area, on the other hand, is the total surface space contained inside that boundary. The best way to remember it? Think of perimeter as the picture frame and area as the painting itself. Keeping these two definitions distinct in your mind completely removes the intimidation factor. Now, what's really interesting about this is how directly we can anchor these formulas to our daily lives. Say you're fencing a backyard because you want to keep the dog from running away. You need the perimeter. You're just measuring that outer boundary. But if you are dropping serious cash to cover a floor with brand new tile or carpet, you need the area. You need the total surface space. Our sources stress that integrating these real-world scenarios is exactly what builds your confidence. You aren't just sitting there calculating formulas, you're figuring out exactly how much flooring you need to buy at the hardware store so you don't end up short on that expensive bathroom tile. And honestly, more importantly, so you don't blow that budget we just balanced. All right, let's add some depth and pop right into the third dimension. Section 3, going 3D, volume and capacity, exploring the space inside solid objects. Just like with perimeter and area, we need to clearly distinguish between two 3D concepts. Volume is all about how much physical space a 3D object takes up. Think of filling a physical box with solid objects, like toys. Capacity, however, is about how much a container can actually hold, and we usually talk about this in terms of liquid. Picture a cylindrical glass filling up with water. They both deal with 3D space, sure, but knowing the difference between the physical space an object occupies versus the liquid a container can hold is the absolute key to mastering spatial geometry. So, the crucial point is how we actually calculate this stuff without getting totally overwhelmed. Our sources break down volume calculations for things like boxes into two incredibly approachable steps. First, just find your flat base area. That's just length times width. And hey, you already know how to do that. Just think of it as slicing the very bottom layer off of a cube. Then, step 2, simply multiply by the height. You're literally just taking that flat base and stacking it up layer by layer by layer. Base area times height, and boom, you're done. Honestly, it's more of a neat mental trick than a math class. Let's shift this directly into a practical scenario. Let's say you're helping your family pack for a move. Now, moving is inherently stressful. Trying to shove a giant, awkward couch into a tiny moving truck is no joke. But this is exactly where applied math steps in to solve a daily hurdle and, thankfully, bring your stress levels way down.
Here is our practical packing problem. You've got a large moving box that is 2 feet long, 1 foot wide, and 1 foot high. You also have a bunch of smaller boxes that are exactly 1 cubic foot each. The goal we need to solve so we can pack efficiently is figuring out exactly how many of those small boxes will neatly fit inside the big one. And this brilliantly illustrates the true power of spatial sense. Because using our little stacking trick from earlier, the answer is a perfectly neat 2. Think about it. We found the base area, 2 feet long times 1 foot wide, gives us a base of 2. We multiply that by the height of 1 foot. 2 times 1 equals an overall volume of 2 cubic feet. Exactly 2 small boxes fit inside. Knowing this allows you to plan with total efficiency. You're mastering the physical space around you instead of just tossing things in, guessing, and hoping the packing tape holds. So let's take a quick second to review what we've uncovered today. We've completely reframed math as an essential everyday toolkit. We balanced equations to master budgeting and personal finance. We used our knowledge of perimeter and area to successfully plan renovations without wasting our hard-earned money. And we used volume to pack efficiently. By integrating these real-world scenarios, we completely demystify those complex ideas and build real practical confidence.
Now that you see how ratios actually balance your bank account, how area carpets your living room, and how volume efficiently packs your moving boxes, you've got the toolkit. You aren't overwhelmed by the numbers anymore. You are completely empowered by them. So here's my question for you. What everyday problem will math help you solve next? Keep observing, and I guarantee you'll start seeing these solutions everywhere you look. Thanks so much for learning with me today.